simple, where you're able to solve everything. Yeah.
Yes, sir.
It was good, sir.
Okay. That's not difficult, right?
No.
Okay. What about the other people? How was it? Are you guys able to hear me or only one person? And the number of people also is coming. Okay, we'll just wait for some time. We'll see. How many of you have gone through the week six lecture? No one, huh?
Yes, sir, I've gone through.
Okay. So if
So
you have
what
not
we
gone,
are going to discuss today?
yeah, we'll discuss week 6 basics. Yeah, logarithm we'll discuss, and then we'll solve some problem. We'll try to make this session as like we'll be having a short session today. Okay, we'll discuss logarithm and whatever there is in the week 6 content, and then we'll try to solve some problem. Is my voice not audible? Is it low?
It is.
No, sir, it is.
Sir, it is audible.
Oh,
Sir, slightly increase the volume, sir. Slightly increase the volume, sir.
good. I have increased it. It's like a full volume from my side. Maybe I will switch off my fan. Is it fine now? Is it clear now?
Yes, sir. Okay, okay. Better.
Okay. Okay, so if you have not gone through the content, please go through the content by today or tomorrow. When is the deadline for week 6?
18th July.
Sir, 18th.
What's the deadline of week?
18th July.
18th. Okay. Today is 15th. Yeah, go through the content. I'll just give you a brief idea today. I will make the session short because
Sir, I will go through the first lecture of the professor, but I am unable to solve the activity questions of that.
no, I
Only
can't
some
hear
of them
you.
I
I
was
can't.
able to solve.
I can't hear you. Is this the same for all or my
Sir,
voice
can you
was
hear me?
not audible, right?
Sir, I'm saying that
Yeah,
I
it's
have
breaking
visited
up.
the first lecture.
So, and yeah, one more thing, any discrepancy that you have felt in the answers of the quiz paper, you have got the answers also, right? So today you would have got the answers also for quiz paper, correct?
I couldn't find out where the answers are. I got a link, but it was towards a form about the quiz. But I couldn't really find that file which has got all the answers.
Is it? Other people, did you get that?
No, sir.
Yes, sir.
I even did not have any answer.
Yes, sir. It's under the particular course, and there is a subsection where we generally watch our videos. So there is a
Correct.
subsection at the end, and then there the file is there.
Yeah, you can check there. So it's there on the portal itself.
Sir, I am unable to find it.
Okay, so can somebody guide if you are so on the portal, which
Even a
section you have found
screenshot
it?
will help.
No, I'm on using tabs and the tab I can't show. I'll have to connect to the laptop. Okay. So what I can do is see mostly what happens whenever you open the portal, right? In the left side, all the folders will be there, right? In the one of the folders, you will be having something else.
For answers, you can go to the module section and then you find the answers in at the bottom of the slides.
Yeah, it says answer key for exam.
Yeah.
Yeah, the questions with the answers will be there, right? We'll be having.
Yes, yes.
Yeah, you can just go and check mostly. So what I felt I got the like we have shared you one Google's like a link also to give an idea about the paper if there is any error or something. As of now, whatever we have received, we haven't received anything about the answers. Like whether the answers are any of the questions has the answers wrong or maybe you feel like the question itself is wrong. We didn't got anything like that till now. So hopefully by tomorrow, if we will not anything, we'll just
Excuse me, sir.
I don't think so there will be any error. We have already checked it twice or thrice. But yeah, then also if you find it, it would be a great, and then you can just let us know so that we can work on that. If there will be any error, we'll just correct it. If there is not, we'll just be releasing the score as it is. Okay. So by tomorrow or day after, I guess, most probably by tomorrow itself, the scores will be out for everyone. Yeah.
Excuse me, sir.
Yeah.
Hello.
Yeah, so somebody has pasted a link also. You can go through this link and then you'll get an idea.
Sir, in week 6 that we have the logarithms, that in the assignments, I mean, problem that in certain sums we have to taking a base different than 10 or e. So in the TCS calculator that is given, we can only take the base as 10, which is log, and then there is the ln where the base is e. Other than that, there is no option to take the base. Suppose in some problems there are base 5, so I cannot take that in calculator.
So don't worry, we'll take care of that. If we'll give you the other values that can't be done with the help of the TCS calculator, we'll give you the value as it is, okay?
So
Maybe
means
let's say example
there are two questions where we have to take the base as 5, log base 5, then something. So and we have to compute the value. So if we take the base 10 or e, then the answer will be wrong. So how to calculate the log?
No, that is what I am saying. No? In the paper, in the examination, it will give anything that can't be, it's not doable with the TCS calculator, will give you the exact value as it is. Like logarithm 5 base 3. If you can't do that, most probably you'll be able to do that because the normal physical calculator, you can change the base, okay? If you are not, okay, we generally give the value also. Let's for example, if you're changing the value base, okay, so you don't have to worry about that. As of now, whatever you are doing at your home, right, there you can use the other calculator also, right? But it is recommended that you should be using the same calculator so that in the exam also
That is what I am telling. The TCS calculator, I cannot take the any other base other than 10 or e.
So if you are not able to, okay, we'll give you the value. I'll also have to check because as of now, you're the first person who are. I'm hearing that you can't change the base. Okay, if you are not able to, we will not be giving you anything that you can't do with the help of the TCS calculator. Okay, so you don't have to worry about that.
Means I'm trying to say that in the calculator there is an option called log yx. So in that option, it seems I can do, but how to do I cannot understand. Means when I'm typing out the thing, it is not taking. This log in the TCS calculator I'm taking. There is
See,
an
you have to
option called
first
log
put your
yx.
number. Wait, Neil, wait. You have to first put your number, then press that log xy, and then you have to put the base number. You'll get the answer. That's how you use that calculator.
We have to first put the number and then the base.
First put the number, then the log xy, and then put the base.
Okay.
Okay, that's how you get that answer.
Okay. Yeah, so hopefully you have somebody has pasted the link also. You can go through that. You can check your answer, whatever that you have marked it, and if you feel like there is any error, you can just let us know. Maybe on the discourse, you can let us know, or maybe the link we have said, right? The review there also you can mention about the which question you feel like the answer is correct.
So I have
to check it from your side. You can check it from your side.
On the chat, I have pasted a little image that shows like what I see when I try to look for the quiz details on the portal. So there are lots of these files. So I'm not able to figure out what is it that I'm supposed to click.
Yeah, in any like most probably you just open any of the you were writing the qualifier or the foundation, the quiz
No,
one.
I wrote foundation level maths.
Like it was a foundation, right? Yeah, so you can open a file named as foundation. There you can find, you can just search it, control F or whatever in the laptop if you're searching, search it maths one, you'll get the maths one paper. Okay.
Okay.
Yeah. That you can do. Yeah. So but you can just, so there are like there were some 3 sets, okay? You'll have to check which set you got, okay, and then you can check it the answer. Okay. So that much work you'll have to do. So we have uploaded all the questions in at one place itself. You have to search it because I guess you can see that there are 3, 4 folders for the foundation, right? 3 folder, 1, 2, 3. So all of them containing 3 different sets. So you can just check which set you got. Huh? Okay. Okay, so I hope this is done. So if you have anything regarding the question paper, you can just let us know. We'll just try to sort that out. We'll start with the today's
Response
session.
sheet means answer key is okay, but the response sheet, like what responses we have given.
What? I can't hear you.
Answer key I understood, but will we get a response sheet like in the exam? What responses we are given, the response sheet like that? Will we get?
That you have remembered, right? You would be knowing, right? What you have marked it.
Yes, whatever we marked in the exam, the list of the response sheet.
Yeah, you will get it after the result will be out. Then you'll get the response with the scores.
Okay.
Like what, for example, marked A and then your answer is correct, then right side you'll be having the scores. Okay. So generally you'll get that. Okay.
And when will the results be out of this foundation quiz one?
Which one? Okay. Or day after that. So in 2, 3 days it will be out.
Okay.
Yeah.
And sir, I would means I have one doubt from graded assignment. Means I will not ask the answer. I will not also ask the method. But another problem is happening. Can you please can I please ask? Hello.
Yeah. So what you were asking? Okay, let's start week 6 now, and then in between whatever doubt that you had.
Sir,
In the week 6 graded, actually, I have a doubt. Means I will not ask the answer. I will not also ask the method. But another type of problem is happening. Week 6 graded assignment.
What is happening?
Means could you please go? Then I can tell to the week 6 GA.
Sir, are we doing summary session of week 6?
Yeah. We'll be doing summary only.
Sir, can I share my screen?
No. You just tell me the question
Can
number, no?
you please give some intro first?
Intro for week 6, sir.
Yes, sir.
Okay, so week 6, I hope you read about the logarithm function. Okay, in week 5, you would have already submitted the graded also, I guess, 1-to-1 function or exponential function you read, right, in week 5. And now you will be reading the inverse of the exponential function, that is logarithm function. Very basic, but then also we'll be just going through the whole logarithm function. Okay, to just give you an idea, we'll try to solve some problem. Normally, it is one of the very basic
go to one's
week of
GA
our
week,
content.
question number 3.
Okay, can we take it in the last after the summary?
Okay.
Yeah. Can you see my screen, everybody?
Yes, sir.
yes.
Sir. Yes, sir.
So here we'll be just be reading about the function. You have already studied about this function, right? What do you call this function? Exponential function, right?
Yes, sir.
Right. Now, if you have to plot, how do you plot this? Let's say example, if you have a greater than 1 and a less than 1, how do you plot this? Tell me, if you have
It's
y
go,
equals to the power
A
x,
less than
what
less
will
than
be the
1 is
plot?
a less than 1 is a decreasing function. A
it's
greater than
go
1 is a
from
increasing
negative
function.
x-axis to positive x-axis and
This is how it will
exponentially
go.
high. Yes,
This is correct.
yes, it will go curvely.
So this
And
is
in the
what? This
tail,
is an
it will
increasing
be
function.
zero. Yes.
Right. Okay. Now, if I have to plot y equals to 0.5 to the power x, how will I plot?
It will goes from positive x-axis to negative x-axis.
Something like this, right?
Yes.
Okay. Now, can you tell me what is the domain of this function? Do you know what do you mean by domain of any function?
Sir, entire
All
R.
real.
Entire
real.
x-axis or real numbers.
Yeah. What do you mean by domain? The value that you can put.
Put in the place of x.
Correct. And that function should be defined.
All
right?
of R.
Yeah. So domain for this function is what? You can put any value from minus infinite
Real number.
to infinite. Correct? Are
Yes.
you able to understand this? So this you can put any value, right?
Yes.
And what are so the domain is R. What is the range of this function?
0 to
What do you mean
positive
by
infinity.
range? A range is the output.
The value
Correct.
of
So that you
we
can see
get.
that any value that I am putting. Correct. So when you are putting the value of x, right, whatever the output that you are getting from output, or you can say the value of the y that you are getting after putting x, right? So this value of y will be your range. Correct?
Yes.
Yes.
Now for this function, any value that I am putting from minus infinite to infinite, what are the value that I am getting?
1 to infinity.
0 to infinity.
What?
0 to positive infinity.
Sir,
Positive
infinity to
infinity.
0?
Minus infinite to 0.5.
No,
Yes, sir,
no,
plus infinite to 0.
no, 0 to infinite. Correct? Anybody has any problem in this? 0 to infinite.
Sir, should we call it infinite to 0 or 0 to infinite? Like how we decide?
No. Whenever you write any values, right, from 1 to 2, so you write the left side, you write the smallest value. Okay. The right side, you write the
Okay.
largest value. Okay.
Sir, is this the week 6 summary?
This is, yeah, we'll start with week 6. We are just telling you what we are going. So logarithm is nothing but the like the inverse of this function. Okay, whatever we are plotting, right? As of now, the logarithm function is nothing but the inverse of this function. Okay, the exponential function. So that's why I'm saying you. So this is a decreasing function, correct?
Yes. Yes.
Now, what about this function? What will be the domain of this function? Is there any difference in the y equals to
0
the
in
power x?
No, no, same.
0 to infinity. 1
No,
to
domain
infinity.
I'm asking. No, domain I'm
Sir,
asking. What is
same.
the domain?
Domain.
Same
Domain is
Minus
real
infinity
number.
to infinity.
Real number, right? And what about the range?
Uh,
0
not
to
including
infinite.
0 and
It's
then
1.
0 to infinity.
It's 1. It's 1 to infinity, I think.
0 to infinity, same.
It will be 0 to infinite, correct? Minus infinite. If you'll see, if you're getting confused, what you can do is just put minus infinite here. If you'll put minus infinite, what will you get? 2 to the power minus infinite. What will you get here? What is the value of 2 to the power minus infinite?
1 upon 2 to the
1.
1 upon 2 to
1
the power.
upon 2 to the power infinite. 1 upon some very big number. 1 upon very big number is what? 0, approximately 0, right? Close to 0,
Yes.
not exactly 0, close to 0, right? So, and then if you will put 2 to the power infinite, then what will you get? Infinite value, right? A very large number that you
Yes.
call it as an infinite, right? So the range will be what?
Yes.
From 0 to infinite.
Infinite. Positive
Is
infinite.
this clear?
Yes, sir.
Yes.
Yes, sir.
Now,
Uh,
yeah.
Left-hand side
So
functions,
whatever
range
I was
Sir,
saying, yeah.
sir,
Okay. So
sir, your voice is
whenever
not
we'll
clear.
deal with the logarithm function, y equals to log x base a. So this you call it as,
Sir, your voice is not clear.
okay. Yeah.
so the
Is
left-hand
it
side part is
breaking
not
or
clear to me.
it's not clear? Huh?
This,
Oh,
how come,
left and this plot
this
you're talking about?
function, yeah, this y raised power, so y equals to 0.5 raised power x. So when if we look at the graph, so it goes
Correct.
from like, y equals to positive infinity towards 0, right?
Correct.
So the range should be actually from infinity to 0 rather than from 0 to infinity, isn't it?
No, so range is the value, the y value that you generally get, right? For I'm not writing that the for minus infinite I should be getting 0 and infinite I should be getting infinite. I'm not writing that. I'm just writing what will be the outcome that you will get for this function y equals to 0.5 to the power infinite x. For any value, for any function that you calculate the range, right? Let's, for example, you are calculating a range for any function.
Mm-hmm.
Y equals to, let's for example, 2x plus 1. Okay, and then you write x equals to some, the x value that you can take it from minus 3 to 5. Okay, when you calculate the range, you don't write it as what are the value that you are getting at minus 3 and what are the value that you are getting at 5, and then you write it in that way. You just write it in that way. What are the value, the combination of value that you get? Let's, for example, you are getting, so not for this example, I'm just giving an example. Any function, if you're getting f1 and the
Mm-hmm.
domain of that function is, let's for example, 1 to 4. Okay,
Mm-hmm.
for any function
Mm-hmm.
fx, the domain is 1 to
Mm-hmm.
4. And if you are getting
Mm-hmm.
f of 1 as, let's for
Mm-hmm.
example, minus 5, okay,
Mm-hmm.
and f of, so plus 5, and f of 4 you are getting as minus 5, something like that. And then in between 1 to 4 you can get any values from minus 5 to 5. So
Mm-hmm.
you will write it in this way, right? Minus 5 to 5 as the range, correct? You will not write it as 5 to minus 5. The normal
Okay.
way that you write
Okay.
the
Okay. Okay.
range, what are the combination that you
Basically,
can get? Yeah. So here
basically range is
also,
a set.
yeah, in that way I'm saying, yeah,
Range is a set
correct.
actually,
The
so
range is
order
a
doesn't matter.
set of, yeah, order doesn't
So
matter,
order
correct.
doesn't matter in set, that's all.
So
Okay. 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 Got it.
in the set, yeah, in the set theory, you would have read about the order also. So in the set, and whenever you write anything, so you can write the combination of anything in a set. Okay, the order doesn't matter normally. That also okay. So where we were,
Mm-hmm.
yeah. So I hope this is clear. The range and domain for exponential function. Now, logarithm function. Okay, so in a logarithm function is nothing but the inverse of your exponential function that you were reading. Okay, and how can, so let's for example you were having this as a logarithm, so this function we were dealing with, okay, where y equals to 2 to the power x. Okay, if you need an exponential function, right, if you need a logarithm function, if you have to get the logarithm function, right, so what you can do is, if you will take the inverse or maybe an image, you can say, in y equals to x, so this will be y equals to x graph, correct? And if you take the image of this graph, this is y equals to 2 to the power x. So whatever the graph that you will be getting, okay, so you'll be getting something like this. So this function that you call it as a logarithm function, y equals to log x base 2. Okay, so x logarithm function that generally we read is nothing but the inverse of your exponential function that you have read in week 5. Okay, is this clear to everybody? So when you write this, the logarithm function, this normally you call it as a base. Okay, so whenever you have been given something like that, right? Y equals to log x base a. Okay, how can you write this? If you have to simplify this, how generally you write? And see, normally logarithm and mostly the logarithm came because you need. So in the starting, if it was normally it came as like you have a very big value, right? And then if you have to represent a very big values, right? Let's for example, a very large values has been given to you, and then you want to represent those numbers in a much smaller, but the continuity should be as it is. Let's for example, you have to represent some values from 1 to some very infinite, very large value in the form of such a way that the value that you should be representing should be in a smaller number, but the continuity that it was following should be as it is. So if you'll see that for any logarithm, let's for example, you have to represent log of 10 and all the base are 10. As of now, I'm just saying, okay, if you have to represent something like 10, 100, 1000, and then 10k, something like that, four number you have to represent. If you will take the help of a logarithm, right, with base 10, this number will become 1, this one number will become 2, and this will become 3. Okay, so now you have to represent the same number with a very small values. Okay, so that is how it came into existence, because the pattern it was following as it is, the number is increasing, here also the number is increasing, but the value, with the help of the logarithm, you can represent a very large value as a very small value, right? So why it came into existence, this is one of the reason that generally people call. Okay, is this clear till now?
Yes,
Can you
sir.
rephrase again? I didn't understand this.
Okay. No, so what I was saying in the starting, see, this came into existence when they have to, in the starting, they have to represent a very large values as a small number, but the continuity that it should be following as it is. Let's, for example, you have to represent this number altogether, 10, 100,000 and 10k, something like that. Okay. And then you can, let's, for example, if you are taking the help of a logarithm of x, log of, let's, for example, whatever the value it is there. So log of 10, if you will take, this is what? 1, right? If you are taking base as 10. Similarly, if you have to represent 100, you can represent this with the help of a log as 2 itself. And 1000 with the help of the logarithm as 3, with the base 10 I'm talking about. So I'm just telling you how it would have came as a existent. Very large number you can represent with the help of a small number itself. Okay, but the continuity that it is following, right? It is same, right? If any function that has been, so any function has been given to you, right? And then if you'll apply logarithm, the pattern that it was following, whether if it was increasing, the function, the log x also will be increasing only. The pattern will not change. Are you getting the idea? See, I have to represent 10,000, 10, 100,000 and 10k. When I applied the logarithm, I got 1, 2, 3, 4. Okay, something like that. I didn't got something like 2, 1, 3. So the pattern, the value, it was increasing, right, from starting to end. So the when I applied the logarithm, the value, the pattern didn't got changed. It was increasing function itself. So here also, if I have to, if you will see that in ML and all, many a times you'll be reading about that. Many a times we will be using logarithm function. Okay, why? To compress the value. So compress means you have to, the pattern it should be following as it is. The function fx was as it is, but when I applied logarithm, my simplification, many of the times we'll be doing a lot of simplification in on function fx, right? When I'll be applying logarithm function log of fx, my the algebra will become very simple, right? Help of the logarithm. So why normally it would have came in existence? Why generally we use the logarithm function? Are you guys able to hear me?
No.
Oh, voice was lagging. Okay.
Yes, sir.
Okay, let
So
me
it
change
was.
the Wi. Yeah. Change my Wi-Fi connection. So I'll change my Wi-Fi connection. Wait a second. Uh, Is it fine now? Is it fine now? Is my
Yeah,
voice
now it's
clear
much
now?
better.
Or
Yeah, it's much better.
it's better? Okay, okay. Yeah, so here it is raining a lot, so that can be a reason. So my
Totally
Wi-Fi is not working. Yeah. So what I was saying, right?
Y function is
See,
discontinuous.
whenever what
Plotted graph, y graph is discontinuous because but your digit is increasing, the power of logarithm is increasing. Mention yes. Why this is discontinuous? What is sometimes it's like sine graph. It's looking like sine graph, but your function is although increasing.
No, that's just
No,
an
I
example.
couldn't get it.
He just gave an example with that graph.
It was just an example. I didn't, yeah, I was not exactly what function fx is. I was just giving you an example that if you have a function, increasing function, right? Whenever you will apply, this is a fx function. If you will apply logarithm also, right? Maybe the function value will get compressed. Here it was 1000, now it will become 3. Here it was 10,000, the value will become 4, right? But the continuous,
Okay.
if it was,
Compressed
yeah.
when we take
So the
logarithm.
nature,
Okay.
yeah, the nature of
Some
the function will
exponential
not change.
function is converted into linear function. Okay.
The nature of the function will not change. So in many of the ML model we will use that like log likelihood and all. Many a times whenever we have to simplify, like it's whenever you will apply logarithm, right, in the coming terms and all, you'll see that it will help you in algebra, right? Whenever you'll do so, many a times what happens whenever you use the log ML estimation and all, so you have a lot of function and then you multiply that. So whenever you take the log of that, then the multiplication will get converted into a summation. So those places generally log helps a lot. So as of now, you can just think of as if you have to represent a very big number, right? Okay, and the nature of those graph or the plot should be as it is. So in those places, you can use the logarithm function. Okay, that's why it came into existence. Now we'll start with that is the domain and the range. So this was not like this is just for the sake of information, but it's not important for solving any problems as it is. So now what I was saying is as any function you would have read, right? If you have any function and you're calculating the inverse of that function, then generally what happens, the domain of the one function will be the range of the other function. So if what?
Voice is not clear.
Oh, isn't okay. You can't do much.
I hear your voice fine.
Me too, sir. It's fine for us.
So voice is
Sir,
clear. Voice is clear, not an issue. You can continue, sir. Your voice is clear.
yeah, it's fine for most of us.
Yeah.
Okay. Yeah. So what I was saying is, whenever in the previous sessions and all, you would have studied, right? If you have a function f, right, and then fx, and then the inverse of this function, let's for example, is gx, right? You already know that for this function, whatever the domain is, this will become the range for this function, correct? And the range for this fx will become the domain.
Yes.
This you have read, right?
Yeah.
Correct? So now, okay, so now you have a function exponential function y equals to a to the power x, right? For this function, you already know that the inverse will be what? Logarithm of ax. So whatever you have read, right, the domain for this function will become the range of this function, and the range of this function will become the domain.
Domain of the proof. Yeah.
Correct? Yeah. And some more properties. So this was very basic. So now if you have to get an idea, right? Let's for example, log of x base 2. Now the plotting, you know, right? How do you plot? You have a 2 to the power x, right? You just take the image into y equals to x. You'll be having the plot of this logarithm of x base 2. So now if you have to plot, right? So you already know that 2 to the power x, you have plotted like this, right? So if you have to plot, just take the image in y equals to x. So this will be something like that. So this is what y equals to logarithm of x base 2, and this is y equals to the power x. So plotting is pretty simple for any logarithm function. Okay.
Sir, I'm
Is this
confused.
clear
What is
to
the
everybody?
image of this? Sir, what is image of this? Sir, I'm confused here.
To take the reflex.
What means
So
of this?
whatever the
Image means.
what image I was just, so if you'll fold, right, this both plot, right, it will get merged in y equals to x. If you'll just fold, right, let's for example you have a paper, right, and you will plot both the plot, right, and if you'll fold it with y equals to x as like what do you call it, a principal axis, right, this both will get merged up.
Okay.
You take the mirror image, right? You don't take like mirror image in
The
a
symmetrical
plain
one.
mirror, right? So you just take this as
Symmetrical.
a plain mirror or something, right? And then take the image, right? So you'll be getting some. So this is what you read, right? In fifth week, you would have read, right? If you have to get the plot of any function, any inverse function, right? How do you get the plot? You generally take the mirror image, right? Or the reflection in y equals to x. You just put y equals to x and then take the image or reflection. Whatever the plot that you'll be getting, right? That will be your plot of your inverted function, right? So for this y equals to 2 to the power x exponential
Sir, can
function.
you give me sorry, can you give me example of we put y is equal to x?
What y equals to?
X, sir, you says if you put y is equal to x, then it's you will find the image of this graph.
No, I'm saying this. Think of this as a mirror, okay? And then take the mirror image of this y equals to 2 to the power. So whatever the plot that you just take, so whatever distance it's there, right? From here, you plot a same value here. Similarly, a distance, whatever the distance that's there, let's for example, this is x distance, then take a value x distance, same. And if you'll keep on doing that, whatever the plot that you'll get, right, that will be the plot of your inverse function. That is what I was trying to say. Okay?
Okay, sir.
So,
Yeah.
so if we have to draw plot graph for y equal to log x,
Okay,
first we
see, if
should.
you want to plot it, right? Okay, no. See, you
So
can
my
plot it
question.
directly also.
Okay.
Yeah, I got your question. You were saying
Okay.
that for every time, do I have to plot the inverse y equals to 2x and then plot the logarithm function plot?
Yes,
No,
sir.
you can
Yes,
do
sir.
it as it is also. Let's, for example, this is what? How do you plot y equals to 2x, 2 to the power x? You just check, right? You just put some random values and then take the, see, to plot any function, right? That's the best idea, is to get an, like, at least pick some 4 5 values, right? Some big, you can't take a value like that are very like nearby, right? You just take randomly 4 5 values, you just plot it, whatever the y that you're getting, and then you merge it, you'll get an approximately similar type of a plot. Not exact plot, you can't plot with the help of like pen and paper, right? Randomly you have to plot. Similarly, you can do for y equals to log x base 2 also. The same thing you can do. Take some values, okay? Some values you take and take that, you can put it in the, like, that should be in the domain of this function, okay? And the domain of this function is what? The range that you got for 2 to the power x. I hope this is very clear. Like, you can just take all some random values and then you plot it, you'll get the plot of this function as it is.
Yes, sir. Okay, sir.
Okay? Yeah. So in the exam, they're not going to ask you the plot. Maybe they can give you a plot and then you have to check whether which of them are the correct plot. But those you can directly check, right? You just put some 4 5 values, 3 4 values, and then you can get an idea, right? Given an option, it's very simple to check which of the following can be a logarithm function plot, right?
Yes, sir.
Yeah. So now, what I was saying. about
It's
the
about
logarithm
range
function.
and range
Yeah.
and domain.
Range and domain. So for the range and domain, right, I was saying any function a x, right? This is a function. Now, what will be the domain of this function? Domain is
0 to
nothing, the range of
infinite.
your
I request
exponential
to
function,
everyone,
right?
please stop the message. I request
What?
to everyone, please stop the message. Sorry, please stop this message because
Okay. Okay. Now you'll have to tell me what is the domain of this function. The domain of this function. The domain is nothing but
0 to infinity, but 0 to
X 0 to
range
infinite.
of y equals to the power x. Okay. So in the starting, I told you, right? What are the range that you can get for this function? 0 to infinite, correct? Yeah. So the domain for this function would be what? 0 to infinite. That means what? You can put the value only from 0 to infinite. You can't put any value negative, right? You can see it from this plot also. So this plot was what? Logarithm function. And you can see that this plot is defined from 0 to infinite, not any values from minus infinite to 0. Are you getting? So 0 plus to
Yes.
infinite, at even not at 0 also. So 0 plus to infinite, the function, the domain of this logarithm function. So in the exam, you will be asked a large number, like there will be some questions where you will be given logarithm of some value. Let's, for example, I'm just asking you, you'll have to tell me. Now, what can be
Sir,
the domain of this
sir,
function?
one doubt, sir. Domain means,
Yeah.
sir, domain refers to A or X.
What?
Sir, in that question, domain refers to X only, right?
Yeah, X only. Okay. If you're getting
Sir,
confused,
sir,
sir,
I'll
अगर
just change
if we put
base and
denominator x is equal to 1, then it's 0.
sir, in that case, if X is a negative means it's not false, right? The domain can be negative also, no? Minus infinity to plus infinity. It can be, X can be -1 or -3, -5, anything.
here you're saying.
Yes, sir.
Okay, logarithm of -1, what will be the value?
-1 means 1 by log of 2 power -1 means 1 by 2, sir.
What we put the power of 2, that means it's equal to -1. What we put
1
power
by
2, that is equal to -1. हम
I can't
2 की
understand.
पावर क्या रखें कि -1 आ जाए? It means.
No, see what I don't know what you are understanding. When I'm writing log 2, this is a base, okay? It's not related to what I'm writing here, okay? This is a totally
Oh, yes, sir.
different thing. This is not 2 to the power x I'm writing. This is a base. This is see what whenever you write logarithm, let's for example, you are writing logarithm of x base 2 equals to y. What does this means? First of all, tell me.
2 raised to y is equal to x.
Power y is equal to x. If we put 2 to the power 3 is equal to 8, then log 2 की power 8 is equal to 3. Like that.
This is what you mean, correct?
Yes, sir.
Yes.
Right?
Yes, sir.
Okay. Now, what I was saying, so you can't take the value x as it. See, this is very simple. When I was saying in the starting, so that's why I started with the exponential function. Exponential function, can you get the y value as negative here? Can you get a y value? No. You just put any value of x, you will always be getting a positive value. You can see that whenever we were plotting this function we plotted, right? When we plotted this function, can you get any negative value? Any y ka value that is negative? If you are putting any value from minus infinite to infinite, will you get any value here?
No.
Are you getting any value? No. That means the range of this function is what? 0 to infinite. You can get a nearby to 0. If it will be minus infinite, maybe it will be something like that, right? But not exactly 0 at minus infinite also, because you'll be getting 1 upon 2 to the power infinite. That's a very big number, but it's not 0. You'll be getting again 0 plus infinite. So here also, if you are getting convinced with that, if you are convinced that the range of this function is from 0 to infinite, then why are you getting confused here? And you already know that for any function, dual function that you're dealing, fx and gx, both are inverse of each other. The range of this function becomes domain of this function, right? So here also, if you are able to calculate the range of this function, that is 0 to infinite, why are you saying that the domain can also have a negative value? Even the plot, when you plotted, right, whenever you have plotted, you have seen that you can take the value from 0 to infinite only. You can't take any value that is 0 minus. Correct? Are you there?
Yeah, we can understand you.
Whoever is asking, right? Is it clear
The
to you?
domain is in this question x plus 1 upon x minus 1.
Okay, for this question, okay.
Yes, sir.
Okay. Can somebody calculate?
Sir, x greater than 0 with 1 excluded.
Yes, sir.
Okay. See, whenever you have to calculate the domain of this type of a function, right? You already know that this value, this total value, not the x, right? When I was writing log of x base a, so this whole value should always be greater than 0. It can't take any value that is less than 0. Even can't take anything that is equals to 0 also. Okay. So here also what you have to equate it x plus 1 upon x minus 1, right? Should be greater than 0. And whatever the value of x that you will be getting, that will be the domain for this function. Is it clear?
Sir, if you put 1.1, then it is valid here.
Here. You just calculate now what are the value that will be getting here.
Okay.
X. If you put 1.1, it will be valid only. What's the issue here?
Yes, sir, it would be
Anything. Yeah.
Okay.
See, if I'm writing log of a, I have not talked about a as of now. The base I have not talked. I'm just talking about this value. So if I'm writing log of 1 minus x base a I have not talked about. You can just think of a as a positive as of now. Okay. Here also, a is not equals to 1, because whenever you were dealing with the exponential function, there also you know that a, we were taking that a should not be equals to 1. If you are taking a equals to 1, that means that becomes a constant function.
0.
All right. Whenever you were writing exponential function y equals to a to the power x, right? We were writing a should not be equals to 1 every time, correct? So here also, a should not be equals to 1. Okay. Is it making sense? Yeah. Now, if I have to calculate the domain of this function, you don't have to do anything. X1 minus x should be greater than 0. Whatever the value of x that you will get, that will be the domain for this function. Okay, where the function is existing. Okay. X is all those values of x where the function will exist. Yeah, go ahead.
So we put my x is equal to -1 -2 here.
What I was saying, 1 minus x should be greater than 0. If I have a function log of x, then here x should be greater than 0. In spite of x, anything I'm writing, log of, let's for example, I've written some very big function.
Okay, I
Log
can
of
understand. Okay, sir,
5
understand.
x square plus 5x plus 1 plus 6x plus 5, right? If I've
X
written
की
this,
value
that
कुछ भी
means
हो
this
सकती है,
should
लेकिन
be greater
log
than
x की
equals
value
to 0.
greater than 0 होनी चाहिए. Okay.
This value should be greater than. Yeah, that is what I was talking, right? Any function that you are putting here, this should be greater than 0. You can't have anything that is less than 0 here, because that is not possible. That we have seen already. Clear to everybody, right?
Yes, sir.
Yeah. And one more thing, the base I told you, right? The base should not be equals to 1 because we have already seen that. In the exponential function also, whenever we are dealing with the exponential function, this should not be equals to 1. If this is equals to 1, that becomes a constant function. Okay, and then you can't take the inverse of that constant function. Okay, is this clear?
Yes, sir.
To everybody?
Yes.
Yeah.
Sir, 0 will not be included in the domain.
What?
Will 0 be included in the domain?
0 is not included. This is 0 plus.
Yes. Okay.
So it never 0, because you have already plotted, right? When you were plotting logarithm function, it was something like this, right? It was not equals to 0 any places, right? It was just closing. So it will get closer and closer, but never touch that. So at 0 also it is not defined, the logarithm function. Yeah, because this is simple, right? Whenever you have this plot, right? This was also not touching 0. It was getting closer and closer. At minus infinite also it was getting just closer and closer, but never it achieved 0. If you would have achieved 0, then we would have told, because this is what? This is just a reflection, right? Of in y equals to x. If this was touching, right? This will also touch, right? Because this was not touching at minus infinite, so this also will not get, right? So at logarithm of 0 is not defined. Okay, you'll get some very big minus infinite value, but not defined sort of things. Is it clear to everybody, right?
Yes.
Okay. Yeah, same thing will happen. And the same thing will happen if you will deal with y equals to logarithm of x base a here, where a is from 0 to 1. We were dealing with two type of exponential function, right? One exponential function we dealt with y equals to a to the power x, where a is greater than 1. One function we dealt with y equals to the power x, where a is between 0 to 1. Correct? We dealt with two type of exponential function, right? In the week 5.
Yes, sir.
A will never be, yeah. So this is the second part. The first part we have dealt, everything is same. The domain of this function will become the range of the other function, and the range for the one will become the domain of this function. Okay, nothing changes here. The same thing will be happening. So here, if you have to plot for any function y equals to 0.5 to the power x, what will happen? The function will be something like that, right?
Yes, sir.
Correct? And if I have to take the reflection in y equals to x, I'll be getting something like that, right? So it will cross here, not be something like that. It will go like this, and this will also cross here like this.
Excuse me, sir.
Yeah.
Sir, can you please mention that reflection formula for taking the reflection?
Reflection, not formula. I'm just saying, whenever you take the mirror image, right, in y equals to x, right? But the function, the plot that you will be getting, that is nothing but the plot of an inverse function, right?
Yes, sir, but I think there was a formula for finding the reflection of any curve about a line.
Formula.
Yes, sir, about a line.
Reflection about a line. I don't have any idea about that. Yeah, there might be formula.
Is not exist, sir.
What?
The symmetry here, I did not find any symmetry here because your first graph is not symmetrical with other. The axis, the main axis where I put the mirror of this graph in this figure.
This is the, see.
He can't draw an exactly perfect graph, man. He's trying to do whatever is possible with the hand-drawn graph.
I think
If
there was
let's
some
say,
Or
confusion
Vishal,
while
can you
reading your
draw
image.
show us in Desmos? These people will better understand there.
yeah, Desmos we can show, but I'm using a tablet, so
Oh, okay,
that
okay,
will be
okay.
difficult for me. Yeah.
Yeah, I understand.
See, any plot, let's say example like. So how do you plot y equals to 0. So something like that you draw, right? Okay, if you have to plot, so if you will take, let's for example, this is your function, right? If I have to, let's for example, there is 1 point here, okay? 1 point here, this point,
So
this
1 by
point,
2 की power, so y is equal to 1 by 2 की power. Suppose let's
this is
1.
y equals to 0.5 to the power x. Okay. Now I have to
1
take
by
this
2.
point. Okay. I have 1 second. Just give me a second. I have to
Okay,
take
so please
reflection. Okay.
mention the x and y point to understand better, sir, because my math is weak.
Okay. No problem. This is x1. I'm writing. This is x2. This is some point 3. If I have to take a reflection, right? Similar in this y equals to x. At which point? So you'll be taking, right? You can take here, right? This point can reflect, right? X1 or not. Similarly, x2 can be here. X3 can be here, something like that. So if I'll just merge this all line, right? And similarly, you can take some point here, this point, and then take the reflection. You'll be getting something like, if I have to take exactly a same distant point from y equals to x.
So give me a mathematical example. Like if we put x is equal to 1, like that. With 1
The
to the
second,
power 1 by 2 to the power 1, 1 by 2 to the power 1 by 4. It's like that.
it's exactly like that. So what I'm saying, sir, is that the second quadrant image will go in the fourth quadrant, right? And the part of the first quadrant will be there in the first quadrant, and it will be from the intersection point towards the, it will increase towards the y-axis. Right.
Yeah. Quadrant wise, you are correct. Yes. Second quadrant will go to fourth. Yeah, one will remain one.
Your voice is not coming.
I think we lost him.
Hey, hi. Sorry. So it got disconnected. Can you hear me now?
Yes, sir. Yes, sir. But the video is not.
Yes.
Okay. Just give me a second. I just lost the host connection. Yeah, by the time I get the host control, yeah, whatever doubt that you have, you can just ask. So till now it's clear, right? So it's not that difficult to understand this. Any doubt as of now?
Your skin is not visible, sir.
Yeah, it's not visible because I'm not sharing it. I don't
Okay,
have the host
so
control
my
now.
doubt
Yeah.
is actually how I draw a graph. Like if you
So
put
any
y
plot, how do
barabar
you draw? No. How do you plot any graph, any other graph? Leave apart this method of taking a reflection or image in y equals to x. Leave apart this. How do you plot any other graph? If you have to plot y
we
equals
put
to
the
x itself,
we
how do you
put the
plot?
function. Yeah. We put the function and the value of in this function of x we get y.
Yeah, you take randomly 4-5 point and then you plot some coordinate, like you for any of the coordinates x, you get a y value, right? So you'll be having some 4-5 of coordinate pair in x1 y1 or x2 y2, some 4-5 pair. You pinpoint on the Cartesian plane and then you merge it to get the plot, right? This is how generally you make a plot, right? For any function.
Yes.
Same thing you do here also. I'm just telling
Okay,
you,
so
this is a very basic method. Any function that you have, if you have to go, like let's for example, many a times what happens in the exam, they'll give you a function. Okay, they want to understand whether you know the concept of this inverse function or not. Okay, and then they can ask you regarding the plot of the inverse function. So this is a normal basic, like fifth week you would have read, whenever you have to get the plot of a function for which the inverse exists, okay, then for those type of a function to directly get the plot without doing anything, you can just take the image in y equals to x and you'll be getting the function. And that is very normal also, right? To get the inverse, right? Inverse is what? For whatever value of x, earlier you were getting the y, now you have to put the y as x and then get the value of y.
So can you speak in Hindi? What is mean of inverse? Can you explain this? In simple word, not English, not Hindi, but in a simple word, like took an example like inverse. Suppose 1 upon 1 by 2 inverse is 2 keep to the power 2. Its inverse is 1 by 4. It's like that.
No, that is not inverse. See, what I was see inverse. How do you check whether for any function? Do you know what do you mean by one function? How do you check whether the function is has like inverse or not? How do you check that first of all? If for any function, the function does that function have one like that the function is inverse has an inverse or not? How do you check that? Do you know?
No.
Okay. Do you know what do you mean by a one function? So you'll have to revise week 5 first of all, and then maybe you'll be in a better position to understand. So many a times you have some test also, right? Horizontal test, line test, vertical line test to check whether the function is one or not, right? Have you read those things or not in week 5?
Because due to qualifier, I skip some
Yeah.
videos.
Okay, so then first go through week 5, right? And they see if
Okay.
you need Hindi recording, right? I only have recorded week 5, 6, 7, 8.
No. I just not understand what is but I see the
No, I'm
lecture.
just giving you an
The
idea.
week.
Yeah. You can just go through those
Okay.
lectures. So if you need that in like the other language, Hindi or something, right? I've recorded the video has been already recorded. You can just go through it. It's not like a very. You can just go through it. I have put in a lot of effort to record those. You can just go through it. You will be able to understand everything. Week 5 and 6. Everything has been taught from the very basic. I've just taught week 1 concepts also, like how for any reflection to be a function, what do you do? Okay, from there we have started. Okay, in week 5 you'll just go through the lectures of that
I have
Hindi wala
shared the
lectures.
drawing. I just drew it on my note and I've shared it. The inverse and the relation. If you want, just take a look at it.
Yeah, that wait, I'll just share my screen.
The one function you use tell about injective function. What do you mean about you tell?
Yes.
Injective function. So it's very easy. Like injective function means so
Okay,
x
now
is equal
even screen
to
so
Sir, I have a doubt in
yeah.
week
This is
6
what you were
graded
saying. Yeah,
assignment.
correct.
Can you
That is
give
what.
me a hint?
Yeah. So just give me a second. We are just finishing off itself. B6. So we were just talking about the logarithm function. So whoever has said this, like the chat box also somebody has said this is also a nice like for a less than 1 and for a greater than 1. Sir. You can see that both the function logarithm function and the exponential function has been plotted. Okay, and you can get an idea also how that taking the reflection in y equals to x or taking the image in y equals to x will give you the that will give you an idea about how the function, like generally the domain and the range get shifted. Okay, that also. You can go to the chat. In the chat box, somebody has posted it. So. Which question you were talking about? The graded assignment, which question you were asking? Can you hear me?
Yeah, we can hear you, yes, but I don't know.
Okay, okay. So now we have dealt about the domain and range. Those are very basic things that you must be knowing. Okay. See, and in the similar way, so whenever the base, so we were talking about the log of x base a, right? There you can have two things, right? A greater than 1 from 0 to 1. In both this x, right? It less than 0. So it always be the domain for this function will always be from 0 to infinite, right? So this is what the read as of now. Okay. And in this same, whenever this a, right? So a is what? A is the base of this domain logarithm function. Whenever this a is equal to e, right? E you would have read, right? Euler's constant. You would have read in maybe in the earlier classes, class 10th and all. The Euler constant, right? The value is normally 2.71. So we just take it as 2.71. It's not the exact value, but generally we take it as. And whenever you will take this base as a Euler's constant, right? You call it as a natural logarithm function, right? So this will y equals to log of x base e. Right? This call it as a natural logarithm function, and everything will be same. You can whatever if you have to plot the function, right? This is what this value is greater than 1, right? So you can just plot it as it is. Whenever we were plotting logarithm of 2. Logarithm of x base 2, right? The function plot everything will be same of logarithm of natural, like the natural logarithm function, whatever we were plotting logarithm of log of e basis. The plot and everything will be same as not the exact value at any point, but the way it will go, both will be an increasing function, right? Both will be having the same domain and range sort of things. Okay. So in that way, both the function resembles the same. Whenever we are plotting logarithm of x base 2, right? We were plotting something like that, right? This also will resemble y equals to logarithm of x base e also. Okay, both are same because both we already know any logarithm function, if the a is greater than or a is between 0 to 1, two type of plot can have a two type of a plot. And here for our case, for a logarithm function, a is equal to 0.71, or you take any use of a, this function, the plot, the nature of this function will be same. And for this function, for any logarithm function where the base is from 0 to 1, it will resemble a different type of a plot. Here, the function will be decreasing, here it will be increasing. So you can just practice it out how to plot this type of a function where a is less than 0 to 1 or from a greater than 1. And that is almost like from the, if you know the exponential function ka plot, you can calculate, you can draw the plot of any logarithm function also. Now we'll move to the basic stuffs about, maybe we'll just study about some of the features of a logarithm function. Okay. Okay, can somebody tell me whether the logarithm function that we have done, is it a 1-1 function or not?
Yes.
It's a 1-1 function.
It's a 1-1 function, right? It's increasing in the domain of
Yes,
0 to
sir.
infinite, right?
It's 1-1.
Correct? So it's a one-on function. Yeah.
Horizontal line test, it will pass.
So it's a one-on function, right? So from there also you can get an idea that you can calculate the inverse of inverse.
I
Now,
have pasted the Desmos graph also in the chat. If you want, you can take it. Can you click and show like Vishal the chat?
yeah. Can you just share it again? Because maybe in the between I lost it, so I don't have anything in the chat.
No, I just shared. No. Oh, okay, I'll share it again.
Hmm.
It goes for everyone, but not you, man.
No, okay.
Okay.
Okay, no problem. Yeah. Maybe in the comment section I can show the Desmos also. Okay. Now, there are some laws that you should be knowing. Okay, first of all, if let's for example, if a function fx and gx both are inverse, what will be the value of f of gx and what will be the value of g of fx?
X. Just X.
X, right? Yeah, correct. So this also you would have read in week 5 itself, right? For any function, let's for example, f of inverse is what f of inverse, right?
Correct.
So if you just calculate f inverse, will be this, and f will be this. Right? This is the basic properties of any function where both are inverse of each other. Okay. So that is how you get the domain of this function from the range of the other, and the range of the other will become the domain. Now, any function, so some properties, and these are the basic properties. Okay. So logarithm of 1 for any base a is value is 0. Okay. The first property you must be knowing logarithm of, if the base is same as for which you have to calculate the logarithm, you generally get it as 1. The value, get it as 1. Logarithm of any value in the form of a multiplication is just converted in the form of a addition. This property generally helps us in ML many times, right? In ML log likelihood estimation and all, there will be taking the help of these properties. Yeah. Similarly, if you have logarithm of a m upon n, the same thing, only here the minus n will come here and will be. Yeah, there are some other important properties. Let's say example you have logarithm of n to the power r. What you can do is you can just write here r. So if you just write it here, logarithm of m base a. Okay. Or you want to write it as a to the power log of am. Here you replace the same thing, right? If you write it here, this will become m to the power log a base a. So this becomes 1, right? So it will be 1. Okay. Here also you do the same thing. Here 1. So same value you are getting. So these are the two most important properties that you'll be using continuously to solve many of the questions. Okay.
The sixth one is 8 base
Now,
per into the base a.
the sixth one.
Yeah, is
Let's
it?
for example, the sixth one I'll tell you. See, if you have 5 to the power log 25 plus 5, what will be the value you'll be getting?
Sir, you're flickering
If
into
you
the
just
screen actually.
We'll have to somehow. I'm really sorry because the net is working with. It's very bad. The network here is very bad today.
This will be
Okay, so if you have to solve it, how will you solve this? How to solve this type of questions?
So this is actually
125 into 0.7.
What?
125 into 0.7.
No, with the properties, take the help.
We will use the property 6 to
25. Answer is 25, no?
No, 125 into 0.7.
It's 5 to the power of log 25 to the base 5, man. So
25 into 5 into 5 or 5 log 5 की value 0.7.
So it will be 25 actually, yeah?
Yes.
So
just
5 to the
25,
power
yes.
5.
No, you're applying both inverse functions one after the other, so it should be just 25.
Yeah, so because log 25 to the base 5 will be 2, right? And now 5 raised by 2 is equals to 25.
Yeah, this can be another. खत्म हो गई सर की बैटरी खत्म हो गई सर नहीं 10% था
Oh, sorry. Can you hear me?
Yes sir, but your voice is a little bit cracking.
Yeah. Is my screen visible? It's not visible or?
It's
Not
visible.
yet.
Yeah, now we are
It's
clear.
black. Yes, it's visible.
Okay. Okay, so voice also is fine or it's lagging?
No, it's good.
No, it's fine.
Clear, it's clear.
Okay. Okay, so what I was saying is this both the properties, right, is very important. And in most of the algorithm problem, you will be using these two properties itself, okay, to solve any of the problem. And one more problem is there, one more property, sorry. So if you have, let's for example, log of x base a, generally you write it as log of, so this x will come at numerator and this will come at denominator. Okay, this is also will be using a lot to solve the problems. Okay, so these three properties that I told you, right, those are the most important. The others you will always be remembering. These three are very basic properties. These three properties that I told you, the last three properties, is very important. Okay.
Vishal, can you scroll a little bit up?
To solve.
Sir, here the equation is 5 log 5 base 5 to the power 25.
No, it's log 25 to the base 5.
See,
That
I'll just
25
write
comes
it as it is. See,
before this.
Okay, I'll just. So this is
Yes, sir,
5
25
to the power.
आगे आ जाएगा ना तो 25
Logarithm
into
of
5 125
25.
और log हाँ सर 25 आगे आ जाएगा ना 25 आगे आएगा तो 5 ऊपर जाएगा तो 5 multiply into log 20
5 logarithm of 5 is how much? 1. I told you this property, logarithm of value. If you are getting the same value as the base, you will be getting as 1. Here also you are getting the same thing. Logarithm of 5 base 5 is 1. So 25 times 1 is 1. Okay.
25 raised to 1 is 20.
25 is to what?
I said 25 raised to power 1 will be 25.
Yeah, 25 raised to power 1 is, yeah, that is.
Sir, you write 25, not 5. Sir, you not write log to the power 2. It's you write log to the power 4. हाँ बट लेकिन 25 और 5 को इंटरचेंज भी तो कर दिया ना, तो 5 log 5 to the power 5 बनेगा, ओवर हो जाएगा.
Yeah, really sorry. So we'll have to close it off because I don't think so. This is helpful at all because in between it's going and then coming the network. Is it clear now? Can we continue?
Yeah,
Can you hear me?
please.
Yes, sir.
Yes, yes.
So this is what I was saying, right? So three properties I told you, right? So the first property that I told you was logarithm of a to the power. Just replace it. You'll be having log m base a.
Vishal, we are
Correct.
not
And the
able to
second
see
property
your.
that I got
So can't see
we're
your
not able-
screen.
screen.
Can't see your screen.
Your screen is like.
Yeah, now we are able to see. Oh, yeah.
See,
Yeah.
the screen.
Yeah.
Okay. So what I was saying, first properties, and then the properties that I was saying, right? Again, this also you can replace it. You'll be left with m, correct? And then log of a base a will be 1 itself. So these two properties. And the third property I was saying is log, if you have been given x base b, you can just write it as logarithm of x upon logarithm of b. So this three properties is very important. Okay. Now, on basis of this properties, can you solve this question e to the power minus x square equals to e to the power x the whole square upon e to the power q? Can you solve this question?
Sir, I confuse in equation 3, sir. Log x upon log.
Equation 3, I told you, right? Yeah, so you just write the whatever that you have been given, right, in the numerator and the base in the denominator. Okay, base you can take any value. You can take any a value, any random value you can take base. Okay.
Sir, can you give an example, like if you put any value like 2, 3, 4, like
Log
so suppose
of,
2
let's
to
for example, 2
yes sir,
and 2.
log 2 to the power 3 is equal yeah, okay.
Log
Sir,
of
no
2
sir,
upon
sir,
log.
sir 1 हो जाएगा ये फिर.
So you are getting, how to what? Yeah. So this
अच्छा,
also is 1,
हाँ.
right?
Sir, x must be the base. Sir,
See,
please take another example, like
logarithm of
2 to the
2
power 3.
base a. Okay, that's fine.
No sir, sir, base put a value a equal to 3, suppose.
Okay, logarithm of this is fine. Is this fine?
Okay.
So we'll be having log of 4 by log of 2. Okay. If we'll take, let's for example, I'm taking 2. So this will be 2, this will be 1. Here also you are getting 2, 1. Correct? Is it? Are you able to understand this?
Yes.
Sir, can you put? I know the value of 2. So can you put this? Can you solve this? Like, 4 आगे चला जाएगा और log 2 की value होती 0.30.
What?
So log 2 की value, the log 2 value is 0.3 and we put the 4, multiply the 4 with 4. So 0.3, 1.2 it's, and 4 log 2 the power 4.
See, anything you take now. Anything you take now, log of 4 is what? 2 into 2 only, right? So log 2 times log 2, right? No, sorry.
It's wrong, sir. Actually,
What?
you take forward 4 and you multiply log 2 with 4. It's 1.2 because log 2 value is 0.3.
I am not able to understand what you
No,
are trying to say.
I think he thinks you can take the 4 and put it in front of log by multiplying by fog, but that's not the case. It's actually log 2 raised to 2, which means you can only take the 2 in front of log.
What he was trying to say, I didn't get that. Like, how can you write, like what you were writing, log 2 ka value, what you were saying something else, right? See, this is very simple. You take any value, any log, like base, it will always be correct. I don't know. See,
So he was directly substituting the values of the logs.
you take any value, log of any value, you take a base b, base you can take any value, that doesn't matter. And this is nothing b to the power, this is nothing like b to the power a, this is log of a, this is exponent, and this is what, this is your base. It's not b to the power a.
Yes, this is not log b to the power a. It's actually log a to the base b. You're reading it in a different
This is log a base b. It's nothing like log b. If I have to write it as exponent at b to the power a, I will say log of b to the power a base some value. Whenever I'm writing log a base b, means base is b. The exponent value for which you have to calculate the log, I'm saying it as a. Whenever I have to write of log of b to the power a, I'll say like this, log of b to the power a base some value. Okay. So you'll have to, whatever I'm saying, that also you'll have to think. Maybe you're getting confused, I can understand that. But whenever I'm writing this, this is base. Okay, here. Now you solve this question. Everybody please solve this question and tell me the value of x. Tell me the value of x for which this function, whatever the value of x you'll be getting, and how many values of x you are getting. How many values of x you are getting?
1 comma minus 3, I'm getting 2 points, 2 values.
Equals to plus minus under root 3.
No, 1 comma minus 3, I guess, is correct. But if you have been asked how many values of x for which this function will exist, then what will be the value? 1 or 2?
2 values.
2 values, right?
Its domain is actually
Yeah.
exponential's
You can
domain
take
is
any
real
value.
number. Yeah,
You
if
can
it's
take
log,
any value.
then
So
yeah,
if it was log, then you would have to
then
check.
I have to reduce, correct.
Correct. So this, everybody will be able to calculate this. See, this is very simple, right? You can, how did you solve that? You can just write it as e to the power minus x square equals to what? E to the power x square minus 3, right? Sorry.
2x minus 3. E to the power
Yeah,
2x
e to the power 2x minus 3. And then you can take the log, ln base e, log base e. Yeah, and then you can solve it. X square equals to 2x minus 3. Then it becomes a quadratic equation. You can solve it. You will get the value of x equals to 1 and minus 3.
So, I'm sorry to ask, but sir, how come it become e to the power 2x?
ln x, वो ln ले लेंगे ना दोनों तरफ. We took both side of ln naturally.
No. I guess what you are asking is e to the power x. This becomes e to the power 2x. This is what you are asking?
Yes, sir. Yes.
So this is what happens now in mathematics.
Power multiply हो जाती है.
पावर मल्टीप्लाई हो जाती है ना.
Oh, okay. That way, yeah.
Okay. So now the next problem you can just solve it as here you'll have to think. Okay, so let's, for example, you have been given something like the where okay, so you'll have to solve.
उस क्वेश्चन में डोमेन क्या कह रहे थे सर? वो जो सॉल्व किया था उसमें डोमेन की बात आई थी.
No, this is fine. For exponential function, for domain, you already know that, right? X can take any value for any
Okay.
exponential function, right? That is what
Okay.
I was saying. If it was a logarithm function, you'll have to check whether the value that you are getting in the end, whether exactly that comes in the domain of that function or not. Okay. So if you have to solve something like 9 to the power x minus 2 times 3 to the power x plus 1 minus 27 equals to 0, then what will be the value of x and how many values of x are the correct solution of this quadratic equation, or the whatever the equation that has been given, exponential equation has been given to you.
Answer will be 9. 3 to the power x equals to 2.
How many solutions you are getting? X equals to 2. Any other solution?
So that will be rejected.
That will be rejected. Okay. Everybody got that right?
No, sir, not at all. Not able to proceed.
Okay. So just take y equals to 3x now. If you will take y equals to 3x, what will be the value of 9x? 9 to the power x? It will be about 2x, right?
Yes, sir, two
9 is
values,
2
9 and minus 3.
9 and minus 3, you have what? 9 and minus 3. But you would have equated 3 to the power x equals to 9, right?
Yes,
You'll
sir,
have to
it
get
will
the
be
value
1
of
and
x,
2.
right?
1 and
1 and
1 and
can
2.
you get 3 to the power x equals to minus 3? Can you get any value of x for which the value 3 to the power x equals to minus 3? I've already read that any exponential function, for any exponential function, when you will plot it, right, can you get a negative value?
No,
No, right? So this will get rejected, right? So you'll be left with only 1 to the power x equals to 9. So here x equals to 2 will be the answer. Okay.
I mean, we
And
never
for
take
those who are
negative
not
values
able to
for this.
understand, so what you can, what?
We never take negative value in any exponential equation.
You don't take
Is it
exponent
correct?
because you already in the starting. No, see, for any exponential function, okay, when you plot, can you get the range as negative? You can't get, right? For any functions,
Okay.
5 to the power x, right? Any value, put the value of x, right? Any negative, positive, any value. 5 to the power minus 5 you put, or 5 to the power 5 you put. You can't get a negative value, right?
Okay, sir. Okay, sir. So
Hmm.
here we how can I solve this? We put the left side of 27 and then solve it.
No, I just did it. Y equals to 3x you take. 3 to the power x you take. Let's assume, you just assume that y equals to, because this you're not able to solve it. What you can try is, you try to convert that to simplify, you try to simplify this. And how will
9,
you
9,
simplify?
27 type.
You
Okay.
just,
Hint 9
y
and
equals to,
27. Okay.
okay, yeah. Anyone else has any doubt in this? How will you solve this one? Log x plus 1 base 8. So whenever I'm saying something, it's not 8 to the power x plus 1. I'm saying whatever I'm saying, you just think like, you have to hear. Okay, so log of x plus 1 base 8 plus log of x minus 1 base 8 equals to 1. Can you tell me the value of x?
So, okay, sir. X equals to plus minus 3. X equals to 3
X
only.
equals to
Minus
plus
3 will be rejected. Minus 3 will be rejected. Only 3.
Yeah, minus 3 will be rejected. Please solve, everybody, please try to solve this.
X equal to 1, no?
X equals to 1.
X equal to
No, I don't think so.
plus 3.
Plus root 2 minus root 2?
No, plus minus root
Equal
2
to
is not
3.
correct. I guess x equals to 3 is correct. You can just put
Yes.
here also. It will
So
put
plus
here, right?
minus 3, so we do not take minus 3 in this.
Yes,
No,
because
minus
it,
3, why are we not taking? Because if we
because of
put
x minus 1, it
3
will
here,
not
right?
satisfy
No,
the domain.
yeah, correct. So, see, you already know that for any logarithm function, the domain is what? X plus 1 greater than 0 here and x minus 1 greater than 0 here. So, x should be greater than 1 from here and x should be greater than minus 1 from here. So, if you'll just take the intersection, what is x should be greater than 1? So, any value for which x is greater than 1, that should be the answer. You got x equals to x, what?
X equal to 3 actually.
X equals to 3 is correct. Yeah, so x equals to 3
because the
don't
other
say in
side is
between,
log,
like, if you want
log
to
8 to the base of 8.
8 with the base of 8. No, here it is log x minus 1 and x plus 1.
Yeah. So that becomes log 8 into x plus 1 into x minus 1. That's x square minus 1.
Yeah, correct.
And on the other side, you can consider it as log 8 to the base of 8 because that is 1.
Yeah, correct.
So you can remove the log on both sides. So it becomes a x square minus 1 is equal to 8.
Correct. And then it becomes x square equals to 9 and then x equals to plus minus 3. But minus 3 you can't take because if you put here minus 3, this function will be having negative value. That you can't take.
Okay. That makes sense.
Yeah. Okay, so that's why you have to take any values which are greater than x greater than 1. That can only be the value that you can put here. That is in the domain. Right? Now you have to solve it. While solving, you got the value as x equals to 3 and minus 3. Minus 3 can't be possible because you already know that the domain of this function itself is x greater than 1. So x equals to 3 is the only option that is left with you. Okay. Any doubt anybody has?
No, sir.
Sir, the previous equation, which was 9 to the power x, if you can just help a bit in that.
Yeah, this equation, you just take y equals to 3 to the power x. If you take y equals to 3 to the
Your
power
voice
x,
is very easy, please.
how
Please,
will you write
repeat it.
9 to the power x? Okay, what I was saying is this equation is what? 9 to the power x minus 2 times 3 to the power x plus 1 minus 27 equals to 0. By just seeing it in the first glance, you're not able to solve it, right? What we can do is you can just take y equals to 3 to the power x. If you will take y equal to 3 to the power x, what will be the value of 9 to the power x? That will be what?
I square.
3 to power 2. Okay.
Correct. 3 to the power, yeah. So this 9 you can write it as 3 to the power 2 x. So that will becomes 3 to the power 2x, right? And then minus 2 times 3 times 3 to the power x. That becomes y, correct? Because
6y.
y we have already taken it. Yeah, correct. 6y minus 27. So this 3 to the power 2x, what you can write, because you already know that y is equals to 3 to the power x, right? If you just do the square, this will become 3 to the power 2x, right? So now this is y square minus
3 to power x plus 1.
You can split this, right? 2 times 3 to the power x into 3. You can write it as it is, right? This 3 to the power x is what? Y. So 2 into 3 is 6. Correct?
Okay. So 6y. ठीक है.
Yeah.
So where 3 कहाँ गया फिर?
Which 3?
3 तो अरे तो वो 18 हो जाएगा ना सर? अच्छा y पुट कर दिया. ठीक है. Okay सर. Okay sir.
Okay. Anybody has any issue? Can we move
Sir,
to the
got it
next
now.
part?
Got it now, sir.
In,
Thank
in
you.
the next question, can you just help me explain, that minus 3 part? Why will not we take minus 3?
Sir. Then what happened?
Okay.
Then I put this value. Then what happened? Then what I solve here? Question क्या था यहाँ पे? In previous question.
You have to calculate the value of x for which the function is you have to solve it and get the value of x for which the solution of this function.
Okay. Yeah. Okay. Value of x.
Okay. So this equation, yeah. So this question, the question is log of x plus 1 base 8 plus log of x minus 1 base 8 equals to 1. Correct? I have to calculate the value of x, or with the, you have to basically solve the equation and get the value of x. Now, before solving itself, what you will try to do is to calculate the domain of this function. So from this logarithm of x plus 1 base 8, what is the domain that you are getting? X should be greater than minus 1. Here you are getting x should be greater than 1. Correct? If you will take the intersection, right? So for this function,
okay.
the domain will always be greater than 1. Okay, now you solve it. And after solving, you got the value as x equals to minus 3 and x equals to 3. Minus 3 is not in the domain itself. So x
Yeah, got
minus
it.
3 can't be the answer. You got it, right?
Yeah.
Okay. Let's move to the next question. Now you have to solve it. This is ln of x square equals to ln of x ka whole square. This is whole square. Now solve this equation and give me the value of x.
So e square, x equals to e square.
Correct.
X equal to 2.
Any other value? E square is correct. Anything else? You'll get two values here.
And one value will be 1.
So because x equals to 1, so directly I'm putting, and then I'm seeing that the value I'm getting it as correct. The equation is left hand and right hand side is getting equated. If I'll put x equals to 1 here.
Yes, sir. 1 and e square.
Correct. 1 and e square. What about other people?
I don't know how you get two values. E square I'm getting.
Yes, same sir. Only 2 square I can reach.
Okay. See, if I'll just solve it.
No,
how
you
can
would
you
have actually cancelled both x on both sides. You shouldn't do that. You should take the
Yeah.
x on the one side and then take x outside. Then you'll have x equal to 0.
That's,
So that means
that's
you'll have x equal to
yeah.
1.
So if you have to this, can you write this as 2 log ln log whatever you want to write it as?
2 ln mod x will it be?
Mod x. Okay.
2 ln x on one side.
Will it be 2 ln x or 2 ln mod x?
Okay. There are 2 ln x. Okay. You're just replacing. So this x square that you have, you can just write it here, right? I told you one of the properties, right? You can just write it here. One of the properties I told you, right? In one of the properties that I was writing, right? Logarithm of something m to the power r. This you can compare, right? So here we are doing the same thing. This square, this 2 right? You can replace this one with this 2. So you got 2 ln x equals to ln of x ka whole square. Ln x I can just take it as any value. Let's, for example, I'm taking 2 of y equals to y square. So y square minus 2y equals to 0. So y value I'm getting as 0 and 2. Correct? So y I have equated to ln of x. 1y I got it as 0. What are the values of x that I can get? So x can be equals to 1 from here. The other part is what? 2, right? 2 equals to ln of x, right? So x ka value, what we can get? X equals to e square, right?
Okay, sir. Okay. Yeah.
Got it, right?
Yeah.
So how I looked at it is like so on one side you have 2 ln x and the other side is ln x into ln x, right? So
correct.
Out of that one, you can cancel out 1 ln x on each side, no?
But you can cancel out, that is fine, but you'll have to take care of those values also, right? ln x and ln x you cancel, but there were some point, right? So see, here also you can cancel y, right? That is fine, but this y equals to 0, if you'll put, you're like, that also can be a solution, right?
Okay.
So ln of x you cancel, but ln of x equals to 0, that also can be one solution, right?
Yeah, because it's a quadratic equation, there will be two solutions.
Yeah, see, y
Algebra, you shouldn't
square
cancel
equals
when
to
you're
2y,
actually
right?
solving.
Correct. You can't cancel, but I'm just saying if you're canceling also, you have to take care of the first of all, you should not cancel, but if let's for example you're removing directly, so take care of all those values where this y is getting 0. That also you should be having in your back of the mind. Well, let's for example, you're solving very quickly. Many a times you just cancel it. So, but that if you're just removing that y term, right? Everywhere it is y term is there. Just take care of those values also where y is getting 0. Okay. So here also you can see that.
Okay.
If you're, let's for example, you're canceling, you're just solving it very quickly. Like many times you can normally solve it. Many times you don't write it as it is. Maybe that's a wrong method, but you just think of in your back of the mind, right? That y equals to 0 also is a solution whenever you are removing y. Okay. That itself
Sure.
becomes a solution. Yeah. So here also, whenever you are removing ln x, so you have to take care of those x values where the ln x itself is getting 0. So if you are doing that thing, then when you are canceling your solution, at the end of the day, your solution will be correct. The method is incorrect, but the solution you'll be getting is correct.
Okay. Okay. Thanks.
Yeah. So this is the last question. Let's try this. Log of x base 3 plus log of x base 4.
I found this on the web form. Plus log on. Check it out.
What is this? CD.
Reopen.
Okay. Yeah, try this. That here you can use the third properties. The three properties I told you, right? There are other properties also, but the three I told you is the most important, right? You can use the third one. That was what log b base a is equals to log of b upon log of a.
The answer is very awkward.
What?
The answer is very awkward.
Actually?
I'm getting very awkward answer.
Yeah, the answer is very awkward. Yeah, very random answer will be getting. There is no direct answer for this question.
4 log 3 log 4 upon log 4 plus log 3.
Yeah, correct. Yeah, now tell me whichever graded assignment that you are facing issue, just let me know the question number. You can just solve it, right? This is easy, right? The answer will be very like random, but yeah, the method.
But can we leave the answer as the log of x is equal to something, or should we actually say, okay, 10 raised to whatever the answer is, what the value of x is?
Yeah, if in the exam they're asking you, they'll ask you the exact value. But if you have been given the options in the form of a log itself, then that's a good, right? But mostly it will not be asked in the exam where you'll be having some random values as answer. Mostly in the exam, you'll be getting some nice answer, like integer form or maybe in the decimal also, but at least some nice value.
Okay.
Can you
Okay,
change
which question?
the activity question 1, question 3?
Okay, somebody is asking it graded, right? Graded, can you just let me know which graded question you are
Can
asking?
I please solve this question which you displayed base 3 as base 4x is equal to 4?
Okay, this question we're talking.
Yes, sir.
Okay, so this question, see, you can just solve it at log x by log 3, log x by log 4 equals to 4. Log x can take ln x can take
Log x, yeah.
as common. Yeah, log e plus log of 4 equals to 4.
Yes, sir. Yeah, minus.
So ln of x equals to what? 4 upon this 1 upon log x 3 plus 1 on 4. X equals to what? E to the power of those value. This is just a random, because you can't simplify this thing same. Like, so you can't simplify this question. You can simplify here, but you can simplify like
Suppose
what
1
you
upon
want.
log 3 log plus 1 upon log 4 is equal to y, then it is very simple.
Yeah, so you can just solve it like this. Something like you're left with what, e to the power 4 times upon log of 4 plus log of 3 upon log of 4 times 4 log of 3, correct? So this will be what? This you can simplify. So you'll be left with e to the power 4 times log of 4 log of 3 by log of 12, right? This will be the answer. E to the power 4 times ln 4 ln, if you want to write any base, you can take 3 upon ln 12. I just took e as a base. Okay, thanks. Got it right?
Sir, I have a question. Because
I
we
want
could
a screenshot of this. Can you please? Sir, I want to take
No,
out of the
what?
solution. Can you please?
What happened?
Sir, I want to
Here,
take
I didn't do
screenshot of
anything.
this solution. Can you please zoom out the screen?
Okay. Is this fine? This.
Sir, I have a question here.
Then?
Sir,
Yeah.
in the second step, when we were taking any random base, couldn't we assume that it's a base 10?
You
And
can take
then,
any base.
and then we will, using a calculator, will know the value of 1 upon log 3
Yeah, you
on
can
base 10.
calculate that also. Yeah, you can. That also you can do.
No, sir. So
Anything
we
you can
take.
do. You take.
So we take
Show
12
the
base.
second page also.
So
But see, anything you take, any base you take. In the end, you have to.
Sir. Hello.
Yeah, yeah.
Sir, can you please show the second page?
Any doubt? Anybody has any doubt in this?
No, doubt here, but sir, what is the range of this? It's mean the value of x is range.
No, you will get exact value, right? You get some exact value. ln of 4 has some value, ln of 3 has some value, ln of 12 has some value. You get some exact value, right? How can you get a range? Like you have to get the value of x for x equation. The LHS and R is equal, right? You'll get some extra value, one fixed value, 1 point. Okay. Any doubt in any of the question that we have solved today?
Sir, the basically जो journal method है वो बता दीजिए, because it's my first time like this type of situation. मतलब सबसे पहले हम
Can you please mute yourself?
Yes, sir.
Go ahead.
सर सबसे पहले हम वो इक्वेशन में कॉमन पॉइंट ढूंढते हैं, जैसे आपने वहां पे 27 था, 2 into 3 था, तो 3 to power x लिया, उसको y माना। ऐसे ऐसे ही स्टेप चलते हैं। ऐसे इसमें किया कि सबसे पहले आपने log b एक a base to b to the power a base b.
Now, see, what was the other option? We were not having any other options, right, to solve this.
Okay. So
do
no,
we have
sir,
any other option to solve? No,
so
right?
what is a common basic method that we apply in all questions like
Correct. So, yeah, whatever the property, yeah. So four properties that we have, right, of logarithm, you'll have to use those properties itself to solving any question. So the three properties that I told you, the in three properties, those are the important properties. Okay, you'll have to solve all those with the help of those properties. Okay. Any other doubts anybody has?
so one function is actually injective function. So you
Any other doubt from this week? Yeah, you're correct. Any other doubt anybody has?
No, sir.
Can you
Please,
ask a question from the activity questions?
which activity? Yeah, just go ahead. Yeah,
Week
we'll
6.
go. Yeah, which question? Week 6?
Week 6, first activity and third one.
Third one, right?
Oh,
Yeah, we'll have to calculate the domain of this function.
correct. I was able to understand up to 10 power 3 and 10 power 5, but after that, how that union came, I'm not able to understand that part.
So this question, 10 log of 10 x whole square minus 8 log of 10 x plus 15. Correct? This should be greater than 0, right? After solving, what is the value of x that we are getting here?
Yeah, we get 10 power 3 and 10 power 5.
So you can just solve it as, so if let's say example, we are taking this as t square minus 8t plus 15. This should be greater than 0, correct?
X equals to 10 to the power 3 and 10 to the power 5.
Yeah, so no. What is the value of t that you will be getting here? T square
T,
minus
3 and
5t
5.
minus 3t plus 15 greater than 0. T minus 5 minus 3, t minus 5, right? So you have t minus 5 and t minus 3 then 0. So whenever you solve this type of a problem, what generally you get? So you get something like that, right? So you have 3 here, you have 5 here, correct? So any value less than 3, let's for example, you are putting 0. Is this function satisfying that? Yeah, that is correct, right? This will be not. So your function value will be from minus infinite to 3 and then from 5 to infinite, correct?
No, that's 10 power 3. Like you have to then, t is equal to log x. To
Yeah, correct. Yeah, no, I was saying the x value, the t value will be from minus infinite to 3 and then from 5 to infinite, correct? But you have taken t as what? You have taken log of x base 10. Correct? So t greater than 3. So this should be greater than 3. For this x ka value, what should be the x ka value?
Greater
1000.
X should be greater than what?
10 power 3.
1000.
Yeah, x should be greater.
10 power 3 is 1000.
What about this point? Sorry.
100,000.
No, sorry. This is t less than 3, right? So t less than 3. So 10 to the power, so log of what was their log of base 10 less than 3? So here it should be less than what? 10 to the power 3, correct? From here, t is greater than 5. So log of x base 10 greater than 5. So x should be greater than what? 10 to the 5.
1
Correct?
log.
Yeah, so the value will be what?
Can you
Let's, for example,
can you
x.
go up a little bit? Can you go
Yeah.
up a little bit?
Yeah.
Yeah, here. How did you draw that line 3, 5 plus in between minus and then plus?
So what is the solution of this equation?
The t minus 3, t minus 5.
What are the values of t? No, what are the values of t? So this is t minus 3 times t minus 5 should be greater than 0, right? So you'll have to take all those values of t for which the function is satisfying, right?
Okay.
So is that because
so
between 3 and 5 the y is negative? Is that the reason why we are taking everything from the left of 3, right of 5?
Correct. Yeah. So this is 3, this is 5. Take any values less than 3.
Maybe
0.
you should just draw a parabola so that I mean, I don't know. You can
No. Just can you give me a So take any value less than 3. I have taken 0. You put 0 here. 0 minus 3 times 0 minus 5. Oh, the function is satisfied. So function is satisfied for if the function is satisfied for even a one value. That means from minus infinite till 3 it will satisfy. You take any value. 3 ka thoda sa a little bit also less than 3, right? If you will take this value, this function will satisfy, right? If you will take any value greater than 3 and less than 5, you take any value. Let's, for example, you take 4. That means what? One becomes positive, one will be negative. That means it will not satisfy. So this will not come in the solution of this function.
You're just saying me to do a trial and error and see for myself.
No, this is not hit and trial. This is a method to solve any type of a question.
Okay.
Yeah. See, if
So
it was
something lesser than and something more than like that.
Yeah. So if let's, for example, this was 3 minus t ka whole square times 3 minus 5. Okay. Greater than 5. Then the solution would have been different. Okay. Then you'll have to take this is 3 and this is 5. You take any values. Why I am saying to take you any values? So that you'll not get confused.
Got it.
Got it, right? So this is the equation. This is the solution that you got. The solution is 3 minus 3 plus 3 t greater than 5. Okay. Or you can say union. Okay, of these two. So if from here you'll get this as a solution, from here you'll get this as a solution. Got it, right? Oh.
Sir, what they actually want to ask, sir, क्या question था? एक बार फिर से explain कर दीजिए just.
You first go and try this activity question 6.1 question number 3. Without trying that question, it will be very difficult to understand.
Okay.
Like first you should try, right, and then you can go ahead. If you are not able to, maybe in the next session you can ask. Yeah. Anything else? Whoever has not gone through the lecture, please go through the lectures. Okay. If you want to go watch in the Hindi also is there. You can watch that lecture. Okay. That has been recorded by me itself. So you can just go through that lecture. So week 5 and 6. Okay. And then if you want to watch the lectures, prof lecture is also there. You can watch those also. And then whatever doubt that you have, you can come up with it. Because most of you have not gone through the content itself.
Okay, I have a
Qualifier का result कब तक आ जाएगा सर?
No, by tomorrow or day after. Maximum by tomorrow itself. Like day after tomorrow for sure. So it will take some 1 to maximum days. So today it said that tomorrow we'll just wait for any query or anything if anybody has any discrepancy in the answers or something. If we'll not get anything, we'll just be releasing the scores by tomorrow itself.
These question results are also written tomorrow.
1 to 8 or 5 to 8?
The quiz 2 will be week 5 to 8.
Okay.
I have some questions over the activity question which I'm finding it. Should I take it this right now or shall we do it the next session? It's already 10:10.
Yeah. I'll also go for dinner. So yeah, we can discuss in the next session.
Okay.
Okay, so thanks everyone. So hopefully it would have helped you in some or other way. Yeah.
Thank you so much, sir. It's a great help.
Thanks. Thanks, everyone. Let's meet in some of the other sessions.
Right. Thank you.
Bye bye.
Bye and have a good day. Okay. Bye.